So we're going to take a look at NH3, which is ammonia. We're asked to draw a Lewis dot structure for the molecule. The first thing is to write nitrogen. Nitrogen is in group 5, and therefore you're going to put 5 valence electrons around it. Remember, 2 of them will be paired, as in the Aufbau diagram, and 3 of them will be unpaired, as it would be in the Aufbau diagram on the outer energy level. We then need to add the hydrogens. Hydrogen is in group 1 and has 1 valence electron. And we then show the sharing of electrons. Those hydrogens believe they have 2, so they think they are like helium, and that nitrogen believes that it has 8 and believes that it is neon. Name the shape of the molecule. So what this is if we take a look at it, we have got 1, 2, 3 bonds, as well as this lone pair of electrons, which is going to push, because of electron repulsion, it's going to push those hydrogens down slightly, creating a trigonal pyramidal shape. Discuss the polarity of the bonds and the molecule. So each bond, if I take a look at the electronegativity difference, the electronegativity of nitrogen is 3. The electronegativity of hydrogen is 2,1. So therefore, my electronegativity difference in that bond over there is going to be 0,9. That results in a polar covalent bond, with the hydrogen being slightly positive and the nitrogen being slightly negative. What that does for the polarity of the molecule is I'm going to land up with nitrogen. Remember that these hydrogens are actually slightly angled down, and we've got this lone pair of electrons up at the top there. This side of the molecule, the side closest to the lone pair, will be slightly negative, and this band of slightly negative hydrogens over here would land up making that side of the molecule slightly positive. So I land up with a polar covalent bond and a polar covalent molecule, with the polarity slightly positive on the nitrogen side and slightly negative on the nitrogen side and slightly positive on the hydrogen side. If I'm asked to look at ammonium sulfate, first I have to get the relative formula mass of ammonium sulfate. And before I can get the mass, I'm going to need to get the formula. So let's try and get that formula. Ammonium is NH4. You need to know that off by heart. And it as a group has a valency of 1 because it's NH4+. Sulfate is SO4, 2-. Again, you need to know that off by heart. And it has a valency of 2. Just going to unpack that. I need another ammonium, and that means that the formula for ammonium sulfate is NH4. I put a bracket around it because there are now 2 of that group, and then I go on to say sulfate, there's only 1 of the sulfate group. Now I can take the trouble to work out the molar mass of that particular substance. So the molar mass, there are going to be 2 nitrogens at 14, 8 hydrogens at 1 sulfate 32, and 4 oxygens at 16 each. So that is going to turn out to be equal to 2 times 14 plus 4 times 1 plus 32 plus 4 times 16, and I land up in total with 132 grams per mole. Calculate the mass of ammonium sulfate in 2,5 moles. If I've got a molar mass and I've got a number of moles, I can use the formula. It's given to me on my information sheet, but you can also convert it into a triangle. Number of moles is mass over molar mass. So if I'm working out the mass, it's number of moles times molar mass, 2,5 times by 132, and I land up with 330 grams. How many ammonium sulfate particles does that represent? Remember, ammonium sulfate is not actually a molecule as such. It's an ionically bonded lattice. So when I'm talking about the particles of ammonium sulfate, I'm really saying how many times does this ratio repeat itself. It hasn't formed an actual molecule. It's more of an attraction between two different ions. But I'm going to pretend that it is a molecule because the way I do the calculation is exactly as if it was a molecule. And it really is quite easy. I've been given a number of moles, and there is another triangle that I could use. I could say number of moles is equal to number of particles over Avogadro's number. So if I'm looking for the number of particles, it is number of moles times by Avogadro's number, which is going to be 2,5, times by 6,022 times 10 to the power of 23. That's given to you on your information sheet, and you land up with 1,5 times 10 to the power of 24 particles. Now, as I've just mentioned, ammonium sulfate is actually ionically bonded. So I'm going to look at the dissolution. What happens when I put ammonium sulfate into water? I'm going to get NH4 bracket 2 SO4 into water, and the ions are going to break up. I am going to get the positive ions separating from the negative ion. And I represent that by saying NH4 plus, how many of them do I have? I have 2 of them, plus SO4, 2 minus. I also need to put my phases in. This was a solid. The water is on the arrow showing that I've put it into water. But then I need to just put a subscript AQ after each of the ions to show that I understand that those ions are now dissolved in water. Remember that once I've dissolved an ionic salt in water, that substance is able to conduct electricity because these ions are free to move. Charged particles that are free to move. How many ammonium ions are present in 2,5 moles of ammonium sulfate? Now we've already worked out that in 2,5 moles of ammonium sulfate, I've got 1,5 times 10 to the power of 24 particles. These particles, there is a relationship between ammonium sulfate, a ratio, and ammonium ion. I'm going to have a 1, there's an invisible 1 over there, to 2 ratio. So for every 1 particle of ammonium sulfate that I have, I will manage to produce 2 ammonium ions. I don't have 1 particle, I have 1,5 times 10 to the 24. What did I do to the number 1 to turn it into the number 2? I multiplied by 2. So I need to take the number 1,5 times 10 to the 24, multiply it by 2, and I land up getting 3 times 10 to the 24 ammonium particles. And what are those particles? Ammonium is actually ions. So it's 3 times 10 to the power of 24 ions. And the last thing I have to do is how much water needs to be added to those 2,5 moles of ammonium sulfate to get a solution of concentration 0,1 moles per cubic decimeter. Really easy. It's not a dilution. It's not anything fancy. All I need to do is this equation. Concentration is equal to number of moles divided by volume is also on your information sheet. So if I am now trying to work out the volume, it's equal to the number of moles divided by the concentration. The number of moles that they have given me is 2,5. The concentration is 0,1, again given in the question, and therefore I would need to add 25 decimeters cubed of water.